Now, this experiment, I'm going to show you how to set up experiment for Hooke's law. First, you need a retort leg. Be sure you have a boss. A boss is actually a clamp. A boss is actually the connector for your clamp. This is your clamp. This is your boss. And the remaining is the holder. First, mount a meter ruler over the clamp. Now be sure it is tangential. You don't want to hold it this way or the other way. You want it to hold parallel line with the leg, parallel line. So be sure that it is tangential. Then you clamp it in, not too tight, don't overdo it. Just make sure it's there tight. I mean, it doesn't hold. I mean, it holds it. Parallel line, okay? Then what happened? You're going to hang your spring given to you. Now depends on the stiffness of the spring. This one is pretty stiff. Okay, linear. Be sure you choose linear, meaning there's a parallel line. This is a linear spring, parallel line. Okay, then you hang it onto the holder here. Okay, push it in. Then what happened? Use a holder, weight holder. Be sure you have 3. 1, 2, 3. This is the base, and then the remaining 2. Okay, because it's a very stiff. We are using a very stiff spring. So even if you hang it, you hardly see anything. So first thing you could do now is to record your first reading. So here, use a ruler if you have a ruler. Find out this height. Okay. Read this reading in the outer scale. Okay. Find out this reading in the outer scale. In this condition, this is 300 gram. Okay. This is my reference. So let me arrange my. Let me reorientate my. Okay. I think I'm going to do it this way. So what happened? Now you add your load. Every 100, add onto it, okay, and then you read the new reading. What is the new reading out here? Okay, be sure your parallel line, read the external scale. You keep on adding. Next one, get a reading. You do not want to drop it, okay? You do not want to drop it. You hold it, your hand hold it down here. Then you gently leave it down. Then you find out the reading. Reading until you fill up all the weight. Here, get a reading, and here get a reading. I do not want to overstress it. I do not want to exceed the limit. Okay, so I think it's all about it. Okay, it's quite good already. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Maybe it's about 1 kg. Maybe another next one. Find out the final reading. Okay, the outer scale. Remember, you read the outer scale, not the inner scale. Read the outer scale is easier. Okay, then what happened? You set up a table. Each of this weight it's about 100 gram. So before you start the experiment, kindly remove from the hanger. Okay, just need to rotate it in such a way that it can be easily removed from the base. Before you start your experiment, you should have a table where you're going to record mass, symbol M, measure in gram, and length of the spring, X perhaps, X length, measure in centimeter. So what happened if you have this table? So what happened? Let's say the initial length, well, start off perhaps 200 gram. The length is say perhaps is 46. When you add another 100 or 200, maybe 200, then it goes to 46.5. Then you add another 200, then you get perhaps 46.7, or perhaps go up to 47. Now those are random number. So I doesn't really know What's the exact number? You need to read from your ruler, okay? Or if you do not want to write in this way, you do not want it to be 200, 300, 200. So add another 200, it becomes, and the mass becomes 400, 600, okay? It depends on the stiffness of the spring. If you add 100 on it, that's not much of increment, then you add 200. So it could be 2, 4, 6, 8, and 1000. You find out what is this length, okay? Maybe repeat 2 times, 2 reading. Then the second reading, then you find out the mean of x. Mean of x, okay? Perhaps this is x1, this is x2. Then you have a mean value. Now once you have that, all you need to do next is rather simple. You just need to plot a graph. The one that you manipulate is actually the mass. The one that is a response is actually the length. Okay, but instead we're going to do it the other way around. The x-axis are supposed to be the manipulated variable that where you actually add on to it. It's supposed to be a mass here. But in this case, we're going to do it the other way around. We do a length x here, measure in perhaps meter versus force Newton. Okay, this for the sake of the learning. So you find out what happened in meter, then plot a graph, and then you report in the classroom what's your finding. Okay, then I'll give you further instruction during the lab session. Thank you for watching my video. Kindly subscribe to my channel for more upcoming video.